All right, folks, we are going to be doing section 2.6 today. That is solving systems of inequalities. When we go to solving a system of inequalities, what we're going to be doing is our main strategy is to graph, because as with any inequality, when we talk just a single inequality and we find a solution, there's usually infinitely many answers. Same with a system of inequalities. You're going to have infinitely many solutions in a contained area, I guess is the best way to put it. And you'll see what I mean. We're going to jump into it here as I go over to my notebook. And we're going to just start out by looking at an example. I think it's the easiest way to do this and the best way to get across what we're trying to do. So I just have to wait for, there we go, my widget to come out here so we can do something. And bring this down. And let's move this. Whoop, I didn't want to do that. I wanted to move that. Okay. So we are going to look at a problem. This over a little bit. Over here. And our problem, they're going to ask you to solve. And it's going to be solved by graphing, they may say. And they'll give you something like this. This is just a basic example to lay out what we're doing. The x less than or equal to 0, y less than or equal to 0, and x plus y greater than or equal to, well, let's just say greater than or equal to, -5. All right, so when we have this and they ask us to solve, what we're going to be doing is what we did with regular inequalities. We're just going to take them one at a time, and we're going to look at them and graph their boundary, decide what kind of line, and then shade. Remember the three-step process. So first, we're graphing x equals 0. Well, x equals 0 is that line that goes, oh, I did not want it to be black. I wanted it to be red. So let's undo that. All right. So x equals 0 is essentially the y-axis, right? And so when we do this, we have that. And we want a solid line because this was less than or equal to. So we graph x equals 0. We got the solid line. Now we need to shade. X less than 0. Less than 0 is to this side. So we will shade this way. All right, so we have that. Now we need to go to the next one. And let's get a different color. So now going to this one, y equals 0. Y equals 0 is, again, going to be a line at y equals 0. So y less than or equal to is going to be right here. And we can do that. And less than, again, it's a solid line because that was less than or equal to. And again, we were just graphing. We just graphed y equals 0, the boundary. And less than 0 would be everything over here. So what we're starting to do is divide up space into sets of solutions. What we can see right now is this third quadrant is the only place that has an answer for both of these. So right now, if we just had these two inequalities, we would just have this unbounded region. It would go on forever, but it would be the entire third quadrant. Everything in it would be a solution. And so we darken that in. But we have one more to do. So let's see if that confines it at all. All right, so we look at this one. And this is x plus y equals -5. And the way I like to do these and the way I generally approach them is I look at if x equals 0, then y equals -5. And if y equals 0, x equals -5. You remember doing this, finding the intercepts? So the intercepts are at -5 and -5. And we need another line. Draw a line through this. We're going to do that and make it blue. So we would have this. And with that, we would have our line. Our boundary line, again, it's solid because of that. Now we have to look at shading this one. This one's a little more work because we have to look at either this side or this side. So I'm going to pick a point, say 0, 0. If I put the point 0, 0 into the original inequality, I would have 0 plus 0 is greater than or equal to -5. And that's true. 0 is greater than -5. So that's true. That means everything on this side of the line would be shaded. So what have we done? We've used to have this whole third quadrant. Now we've cut off part of that. So we end up with this triangle of solutions. In here, there's infinitely many points. There's differently many combinations of x and y that make this true. So we can't describe it other than with this graph, this region, something that your book will also call a polygonal convex set, because this is a convex polygon. And so they will call this also a polygonal, that's supposed to be NaL, polygonal convex set of solutions. Now, to make it a little more obvious, what I usually do is go back and color that in, because it's all the overlaps. It's this. So I color in that triangle to make it more obvious that that is my set of solutions. And that's our solution. That's how we solve by graphing. It's that set. All right. Now, we can go one step further. Now, that one step further, this is the polygonal convex set. If they want the vertices, and they may ask for that, if they want the vertices of this set, because the vertices are going to become important to us later, the vertices would be what? We'd have this, this, and this, the vertices of that polygonal convex set. That would be at, we can call them ABC if we want. It would be at -5, 0. B would be at 0, 0. And C would be at 0, -5. And we would have given them the vertices, only if they ask for it. So we have that. And let's go on and do another problem. All right, let's do this one. All right, I need my setup again. And let's see. I am going to need, whoa, I don't want to do that. All right, let's do this. And I'll move this down. And I'm going to move this up a little bit. All right, same here. All right. So now what is our problem here? They are going to ask you things of this sort. Let me move this over first so it's out of our way. And they will give you a problem like this that will say, find the maximum and minimum values of f of xy equals x plus 2y for the polygonal convex set that occurs at a vertex of polygonal boundaries. All right, lots of words. And what it's basically saying is this. They're going to give us another system, x greater than or equal to 0, y greater than or equal to 0, 2x plus y less than or equal to 12, and x plus 3y less than or equal to 21. So what does this mean? Well, it means we have to first graph this. All right, so we're going to graph the system. We're going to find the polygonal convex set. We're going to find the vertices of that set. And then we're going to plug those vertices into this related function. This function is related to this system. And what we'll find is any max or min values of the solution for this related function are going to happen at those vertices. So we want to plug in the vertices and see what the maximum minimum values would be. All right, so let's start with graphing. So we're going to graph this. First, this one, x equals 0. We just did this on the last one, and we can do it again. Let's do this. X equals 0 is going straight down the y-axis. And we have that. And greater than or equal to would be this side of it. And then we have y greater than or equal to 0. So first we are going to do y equals 0. And y equals 0 would be going across here. And we put our arrows on that. And greater than or equal to would be here, right above it. So we have that. So we're first quadrant right now, but we're not done. We still got two more things to graph, two more inequalities. We got 2x plus y equals 12. Well, 2x plus y equals 12 means when x is 0, y is 12. When y is 0, x is 6. So I can graph the point 6, 0 and the point 0, 12 and connect those. So let's do that. That goes from here to there. And again, we put our arrows on those. And we want to find what side of this side or this side. If I put 0, 0 in here, I would get 0 plus 0 is less than or equal to 12. So 0 is less than 12. So that side works. That means everything on this side works. And we now have a triangle. But we're not done. We still have one more to graph. And let's look at this one. X plus 3y less than or equal to 21. So again, I'm going to look at the boundary. And when x is 0, y is 7. When y is 0, y is 0, x is going to be 21. So I've got the point 21, 0. We'll say that's right there. These are going by 2, so that would be there. And the point 0, 7, which would be, again, right between there. And let's graph this. Let's do that, and this. Now, one thing you see me doing is I'm color coding this. When you do your own work, if you do have colored pencils, I will tell you, it makes it easier when we do the next unit after this, when we get into 2.7, to be able to keep track of which line you were doing if you can kind of color code them. Just something to consider. So now, 0, 0 in here makes this true, so everything below this. So what we did is we cut off the top of that. Whoops, let's not do that. Let's go back here and do that. And now I need black back. What we have now is this region in here, right? Everything inside here. So that's going to be a vertex here, a vertex here, a vertex here, and a vertex here. Well, some of these we already found, right? If I call these, and it's nice sometimes just to key these in so I don't have to draw everything on my graph. I need A, B, C, D, and E. or A, B, C, and D, sorry. A, we know is 0, 0. B, we know is 0, 7. Why is this not liking me do this? All right, there we go. C is not immediately obvious. Looks like it might be 3, 5, or somewhere in there, but let's leave that for a moment. Let's get the ones we already solved for. And 6, 0 is D. So we have all those. Now, how do we find C? C is the intersection of these two lines, right? In other words, this one and this one, the equals. So we can solve that system, can't we? If we go down here and we solve the system, this is for C. If I solve the system, x plus 3y equals 21, and 2x plus y equals 12. This is another example of how we use systems. So maybe I multiply this by 2. If I do that, I would get a new system. That would be 2x plus 6y equals 42, and I would have 2x plus y equals 12. And when I subtract, I would get 5y equals 30. And that means y equals 6. Well, if y equals 6, I can go back to either one of these and say 2x plus 6 equals 12, right? If I use this one. And that would mean that 2x equals 6, so x equals 3. So if we look at that, that's pretty close to what we thought. 3, 6, 3, well, that is 6 right there. So 3, 6 looks pretty good. And that is the solution. If you not use really nicely laid out graphing paper and stuff like that, you can do a lot of this by hand without having to do that solving a system. But I want you to be aware that you could solve the system. Oh, I just moved everything, didn't I? All right. So 3, 6 is what we have. And let me see if I can get this back where it was. Can I? No, I blew it. Oh, it looks pretty close to there. If I move this, no, it's not letting me move it. Hey, look at that. Almost got it back there. Whoa, there we go. All right, so that's what we get. So we've solved this. It says we found the vertices, but we've got one thing left to do. If you remember up here, and let me get a new marker. It said we have to do the function value there. We want max and min values. So now I've got to use these A, B, C, Ds, right? So 0, 0, 0, 7, 3, 6, and 6, 0, and I've got to put them in my function. So if my function, again, my function xy is equal to x plus 2y, I'm going to find f of 0, 0. Get rid of that for a minute. So I need to find f of 0, 0, which would equal 0, right? F of 0, 7. So f of 0, 7 would be 0 plus 14, or 14. And then I need f of 3, 6. Oh, this is bothering me. Didn't have that little piece. I erased it by accident. So that would be 3 plus 12, or 15. And finally, we need f of 6, 0. F of 6, 0 would be 6 plus 0, or 6. So our max value, and they want the max value, not where it happens. They didn't ask for where it happens. They just want the max value. The max value is 15. The minimum value is 0. And that would be the final solution to all that work. So again, look at what we do. First, we graph our system. Second, we find our vertices for the polygonal convex set of solutions. Finally, we look at the function related and we use those as input into the function related to that system and find the max or min values. I just did it again. There we go. All right, so those are your steps to solving this. And there's the final result. All right, you're going to get some practice on these, and we're going to use a lot of this in our next section. So you do want to make sure you practice this well. And again, if you have questions, we'll answer those tomorrow. All right, guys, have a wonderful day, and I will see you again probably tomorrow. All right, so let's stop that.